The night fades differently when the universe is busy. Somewhere beyond the soft horizon of dawn, invisible lines are being drawn, lines of gravity, magnetism, and light threading one world to another. You don't see them, but they hold everything in place. The path of the planets, the rhythm of solar winds, the slow ballet of bodies too far to ever meet. And now in this quiet corner of the solar system, the lines have begun to converge again. Astronomers at NASA and the European Space Agency call it a rare geometric harmony, the moment when the Sun-Earth and a small cluster of comets fall into alignment. They call the newcomers 3I Atlas C 2025 V1 Borisov and A6 Lemon. To you, they sound more like characters in a story, wanderers drawn together by invisible strings, each moving to the same celestial pulse. On November 5th, data from the Solar Dynamics Observatory showed the sun glowing with restless energy. Sunspot region AR3892 rotated into view, a dark blemish roughly 3 times wider than Earth itself. In ultraviolet wavelengths, it looked alive, plasma arcs looping and collapsing, magnetic fields twisting like threads pulled too tight. Scientists measured its output bursts of radiation, reaching X1.7 intensity, among the strongest in months. Each flare sent shockwaves racing through the solar corona at nearly 900 kilometers per second, carrying billions of tons of ionized matter outward. At the same time, NASA's SOHO spacecraft and the twin stereo probes recorded those same waves expanding through the inner heliosphere, the great ocean of solar wind that surrounds every planet. The instruments saw them spread in a halo, brushing past the orbital lanes of Mercury and Venus, then washing into the space between Earth and the incoming 3I Atlas. It was as if the sun had exhaled and the entire solar system was listening. Some astronomers at the ESA's Space Weather Coordination Center noticed something unusual in those data sets. Each flare seemed to aim just a little too perfectly toward the same region, toward the plane where Earth 3I Atlas A6 Lemon and Borisov had lined up in a single razor-thin angle of space. The event wasn't rare, exactly alignments happen often, though not usually with interstellar visitors in the mix. Still, this one felt strange. The timing was exact, the geometry precise. The storms came one after another like a metronome of light, keeping time with something unseen. You imagine it like this: the sun in the center, radiant and vast. The Earth tilted slightly on its axis, magnetic fields flickering like aurora beneath the clouds, and between them, 2 silent travelers catching that storm in their wake. For a moment, it almost looks like choreography, an ancient dance too large to fit inside comprehension. NASA's Parker Solar Probe had already flown deep into the corona, measuring the birthplace of solar wind. It found turbulence and harmony, intertwined small switchbacks in the magnetic field where particles suddenly reverse direction like eddies in an invisible tide. Scientists still don't fully understand why they form, but they know that when these waves reach planets, they shake magnetospheres, compress atmospheres, and ripple through the upper ionosphere like distant thunder rolling through unseen air. And that's what was happening now. The sun's pulse was spreading outward, colliding with fields stirring plasma and tracing the alignment like a finger drawn slowly across glass. If you could see magnetic lines the way telescopes do, the space between 3I Atlas and Earth would glow not brightly, but with quiet tension, the way water glows under the weight of a distant storm. By early November, the Minor Planet Center had updated Borisov's orbital data. It confirmed what most astronomers suspected: its path would skim inside the orbit of Venus before swinging outward again, crossing the Sun-Earth axis almost perfectly. That same week, The Japanese Himawari satellite recorded enhanced auroral activity far beyond expected latitudes, evidence that the solar wind was interacting deeply with Earth's magnetic field. Coincidence, perhaps, but to those who watch the heavens, coincidence and pattern often blur. It's not that the stars whisper secrets, it's that they echo the same rhythm that lives inside you. When you breathe in, your heart beats. When the sun breathes out, the planets tremble. And in between those breaths, something wordless passes through something you can feel without language. Astronomers sometimes joke that alignment is meaningless. Gravity doesn't care about straight lines drawn from Earth's point of view, but magnetism does. So does radiation. So does light. During alignment, the paths of charged particles overlap. The fields that guide them resonate. It's like two musical notes vibrating at the same frequency, amplifying each other's sound. Except in this case, the instrument is an entire solar system. The Solar and Heliospheric Observatory captured it clearly, 3 simultaneous coronal mass ejections, each expanding in nearly perfect symmetry. The data looked beautiful, concentric waves blooming outward from the sun like petals made of fire. And through those waves, the line of alignment glowed with subtle intensity, invisible to the naked eye but recorded by instruments orbiting hundreds of thousands of kilometers away. ESA's analysts noted a small fluctuation in the interplanetary magnetic field, not alarming, but distinct. It was as if the solar wind itself had noticed the geometry and decided to hum along. You think about that word, alignment. In human life, it means agreement, balance, harmony. In the cosmos, it means precision beyond imagination. Everything moves. The sun rotates once every 27 days. The earth spins once every 24 hours. 3i Atlas cuts through space at nearly 67 kilometers per second. And still, for one brief moment, their paths cross a single plane of light. It is a coincidence so fragile that even a second's difference would scatter it apart. And yet here it is, written across the sky like a sentence too beautiful to last. Maybe that's what all science is catching, that single instant before the pattern dissolves. By mid-November, the geomagnetic activity around Earth had begun to intensify. NOAA recorded KP indices climbing towards storm levels again. Auroras spilled southward into Germany and the northern United States. Airline pilots noticed faint flickers of radiation in the upper atmosphere, the aurora's ghostly twin, and while no danger reached the ground sensors in Alaska, Finland, and Japan, all picked up the same vibration, a subtle pulse perfectly in rhythm with the sun's latest flare. If you could translate that pulse into touch, you'd feel it right now, a soft thrum beneath your feet, somewhere deep in the crust where the Earth's core hums back to the solar heartbeat. You've heard people say that everything is connected. Perhaps this is what they mean, not metaphor, but physics, not belief, but resonance. Somewhere far beyond those flares, 3i Atlas keeps brightening. Its nucleus spins slowly, reflecting sunlight from carbon-rich minerals that have crossed light years to arrive here. It does not know of you or of Earth or of the sun's mood, and yet it moves in concert, drawn by gravity, pushed by radiation, guided by chance. Beside it, C-2025 V1. Borisov drifts silently, no tail, no plume, no voice, only reflection. And all around them, plasma continues to hum through space like wind through strings. You listen, though, you don't know what for. You listen because silence this perfect feels like invitation. Have you ever wondered if alignment is only coincidence, or if sometimes the universe arranges its geometry just long enough for someone somewhere to notice? Before dawn, the world is quieter than you think. Even the air seems to hesitate, as if it knows that something vast and unseen is passing overhead. Somewhere beyond the faint curve of the horizon, the sun has not yet risen, but its voice is already reaching you. Invisible waves of charged light leave its surface every second. They cross 150 million kilometers of emptiness to touch your skin, your oceans, your magnetic field. They also touch something else, something that wasn't supposed to be there. Astronomers call it C2025 V1 Borisov, a small, dim traveler moving silently between the interstellar object 3I Atlas and the orbit of Earth. No one expected it. The first time its coordinates appeared on the Minor Planet Electronic Circular, the data looked wrong. An object visible near the constellation Virgo, but without a tail, without the glowing trail that defines a comet. Just a dense point of light. Magnitude 13. Faint, but real. For comparison, the human eye can see only down to magnitude 6. The telescopes that captured Borisov were reaching through blackness deeper than any midnight you've ever known. NASA's Jet Propulsion Laboratory confirmed the trajectory. Only a day later, its path cut directly across the imaginary line that connects the Sun and the Earth, the same path that 3I Atlas had taken weeks before. Astronomers used the SOHO and Punch spacecraft to track solar storms racing toward that region. On October 21st, the first large coronal mass ejection erupted from the Sun's active region, AR 3892, a cloud of plasma traveling at more than 800 kilometers per second. By the time those waves reached the zone between 3I Atlas and Earth, both objects were perfectly aligned with the solar equator, a coincidence that shouldn't have meant anything, and yet it felt like geometry with intent. You picture it: a fiery star, a blue world, and two dark wanderers suspended between them, all caught in one invisible breath of light. Scientists call this kind of moment a synodic alignment, when celestial bodies line up in the same heliocentric longitude. To an astronomer, it's a matter of angles and motion, but to you, listening in the half-light before morning, it sounds more like music, a single silent chord stretched across space. Data from NASA's Solar Dynamics Observatory showed that the October flares were among the strongest in months. A G3-class geomagnetic storm brushed past Earth's magnetosphere, painting auroras over Norway and Alaska. Inside those same hours, radio telescopes recorded an unusual scattering of solar wind. The charged particles seemed to bend slightly near the coordinates of 3I Atlas. Not enough to call it anomalous, not enough to make headlines, just enough for the scientists at ESA's Space Weather Office to mark the observation with a quiet question mark. Somewhere in the background, software kept counting photons, turning night into numbers. And yet, behind all the graphs and wavelengths, there was a feeling as if the cosmos was leaning closer. When the first image of C2025 V1 Borisov was stacked and sharpened, the stars appeared as streaks of motion. They had moved while the telescope stayed fixed on the tiny wanderer. The result was strange. The stars blurred, but the traveler stood still, crisp, steady, silent. It's easy to forget that what you're seeing in those images is not light as you know it. Every pixel is ancient sunlight reflected from an object smaller than a mountain, moving faster than any jet on Earth, perhaps 50,000 kilometers per hour through interplanetary night. And yet, it glows faintly, almost politely, as if trying not to disturb the darkness around it. Astronomers measured its albedo, the percentage of light it reflects, and found it low, darker than charcoal. Still, it shines, not because it burns, but because it refuses to disappear. Sometimes brightness is just persistence. NASA's archived ephemerides show that during those same nights, 3I Atlas began to grow brighter than predicted. Its apparent magnitude jumped from 11.2 to 9.8, a difference that means roughly 2.5 times more luminous. But the increase didn't come with a tail or the typical jets of vapor that comets release when their ice warms. Infrared data from the NEOWISE telescope suggested a surface rich in carbon and metal, not water, hard, solid, unmelting. To scientists, that meant 3I Atlas was likely composed of dense interstellar minerals, perhaps remnants of a broken planet from another system. To poets, it sounded like something else entirely, a message carved in stone, drifting between suns. You breathe slowly and let that image settle. Two objects, one dim, one bright, both silent. A sun that speaks only in storms. A planet yours trembling just enough to listen. It's easy to think that space is empty, but the truth, NASA says, is the opposite. Even the vacuum hums with charged particles, magnetic waves, and invisible radiation fields that link every atom to its star. Space is not silence, it's just a frequency too vast for ears. And in that spectrum, somewhere between the noise of the solar wind and the whisper of cosmic rays, new visitors sometimes appear. They don't announce themselves, they don't leave tales, they simply pass through changing nothing, and yet after they're gone, something feels different, as if the world has remembered a word it once forgot. You imagine standing on a beach before sunrise, the ocean mirroring the black of space. Above you, billions of kilometers away, plasma waves travel outward from the sun like ripples on a pond. Each one carries information, magnetic data, density, temperature, imprinted into light itself. If you could translate that light into sound, it would be a low, endless hum, and perhaps somewhere within it the name of Borisov or Atlas would be hidden the way a secret hides inside breath. Maybe that's why you're here listening. Not to decode it, but to feel it. Astronomy has always been a paradox, to measure what cannot be touched, to describe what will never know your name. But the data are real. The sun did flare on October 21st. The CME did travel toward Earth. The geomagnetic storm did reach G3 intensity. And in those same coordinates, a faint object with no tail drifted between worlds, tracing a path that no human eye had ever seen before. For now, scientists call it natural. But deep down, every astronomer knows that the first step of discovery is wonder, not proof. Maybe that's why even NASA's reports, written in perfect technical calm, still end with words like "further observation required." It's a polite way of saying, we don't know yet. So you close your eyes for a moment and picture the solar system as it truly is, not a clockwork machine, but a sea of magnetism and dust where light itself swims. Each planet a small island of warmth. Each flare a heartbeat echoing through miles of plasma. And in that sea, two wanderers, 3I Atlas and V1 Borisov, drift quietly between tides. They don't roar, they don't sparkle, they simply move, carrying with them the memory of places beyond your star. Maybe that's what the universe is doing right now, remembering itself. And you, small, fragile, awake before dawn, are part of that memory. The sun will rise soon. Its first light will scatter through the upper atmosphere, turning cosmic radiation into color. The same particles that once touched Borisov will touch you, too soft, invisible, ancient. You'll never know which photon traveled the longer way to reach your skin. But every morning you are brushed by the same universe that watches its own travelers glide through the dark. Have you ever felt just before sunrise that something vast was moving behind the light, something watching, waiting, as if the sky itself were holding its breath with you? Some nights, the sky hides its secrets in plain sight. You can look directly at them and never know what you're seeing. That's what happened with C-2025 V1 Borisov, a small shimmer among billions easy to miss unless you knew where to look. But even among astronomers, what they found left them quiet, because Borisov didn't behave like a comet. It had no bright tail, no fountain of ice dust or vapor spilling out behind it, no glimmering streak to betray its motion, only a faint round glow, a soft sphere of light called a coma, moving across the dark like the ghost of a planet. At first, most scientists assumed it was just an observational error. Maybe the exposure was too short, or the light was swallowed by the sun's scattered rays. But then came the confirmation. 10 separate observatories around the world reported the same thing. The International Astronomical Union's circular listed each one. Most of them described no visible tail. 2 mentioned a faint extension, perhaps 50 to 70 arcseconds long, but even those measurements didn't agree with each other. To the naked eye, it was as if Borisov had refused to play by the rules of the solar system. NASA's data placed its brightness near magnitude 13. Dim, yes, but steady. At that level, you wouldn't see it without a telescope, yet in deep exposure, it was undeniably there, a speck of persistence in a moving sky. Astronomers compared it to its far brighter companion, 3I Atlas, which by early November had already reached a magnitude near 9.8, nearly 2.5 times brighter than predictions. But brightness without a tail made both objects strange twins, whispering the same question in different ways. Why are they glowing if nothing burns? To understand that, you have to think of what a comet really is, not fire, not ice, but memory. Each one is a fragment of an ancient beginning, a piece of material left over from the birth of stars. When sunlight touches it, that memory comes alive. Ice sublimates, gas expands dust trails behind it. That's the tale we know. But in Borisov, there was no response. The sunlight touched it, and nothing changed. It did not flare. It did not melt. It only moved. NASA's NEOWISE telescope analyzed its infrared signature. The readings were faint, too faint for water ice. The object reflected heat, not absorbed it. That meant it was composed not of fragile ice and dust, but of carbon and metal-rich minerals materials that could survive the full intensity of solar radiation. In other words, it was ancient rock, a traveler built to last. The discovery reminded scientists of another mystery, Oumuamua, the first known interstellar object discovered in 2017. It too had no visible tail. It too moved in ways that puzzled orbital models. Some researchers, like Harvard astrophysicist Avi Loeb, had even speculated that Oumuamua might have been an artificial fragment, not a comet, but a relic. No one could prove it, of course. But the echo between Oumuamua 3I Atlas and now Borisov was difficult to ignore. It was as if the galaxy were sending a series of riddles, each smaller, dimmer, harder to explain than the last. When Borisov was first captured in high-resolution images, you could see the background stars stretched into tiny white lines, trails of time caught mid-motion. The comet itself stood sharp and still because the telescope had tracked it perfectly across the sky. The result was eerie. The stars looked alive, the comet looked frozen. In that stillness, it almost resembled a spacecraft more than a natural body. No rotation, no spin, only forward motion, steady and silent. Somewhere within it, dust older than your planet was holding itself together, matter from before your sun was born, still remembering its shape. NASA's trajectory projections showed that Borisov was passing inside the orbit of Venus, only a few million kilometers from Earth's orbital plane. It would reach perihelion, its closest approach to the sun, within weeks. yet no tail had formed. That shouldn't have been possible. At that distance, solar radiation is fierce enough to strip surface ice almost instantly. But Borisov simply kept going, unbothered its faint coma, holding steady like a dim halo. The data told one story, the light told another. You picture it again, the sun at the center, its flares unfurling like petals of fire, and somewhere between those petals a small dark pebble sails through, leaving nothing behind. Every second, trillions of photons slam into its surface. Each should scatter, ignite, or vaporize part of it. But the object absorbs them quietly and keeps its silence. Maybe that's why the astronomers began to call it the Quiet One. In the silence of space, brightness means many things. Sometimes it's reflection, sometimes it's defiance, and sometimes it's a form of conversation, light answering light. NASA's Solar and Heliospheric Observatory recorded that Borisov's apparent position coincided with a region of increased solar wind turbulence. The cause: possibly the sun's ongoing X-class flare activity, magnetic ripples traveling outward at hundreds of kilometers per second. When those waves meet an object without a tail, they wrap around it, distort, and continue onward. Like wind curling around a rock in a river, never changing the rock itself. In that sense, Borisov wasn't ignoring the sun. It was listening differently. There's a theory in astrophysics called non-gravitational acceleration. It describes the subtle push that a comet experiences when its gases escape, nudging it slightly off its predicted orbit. That's how scientists usually know a comet is active. But the latest calculations from NASA's Jet Propulsion Laboratory showed almost no measurable deviation in Borisov's path. It moved as if untouched, pure gravitational obedience. To the equations that made it simple, to the imagination it made it profound. Because in a solar system defined by motion, something perfectly steady feels like a miracle. Every time you look at the sky, you're really looking at the past. The light from Borisov that reaches telescopes tonight left days ago, traveling through dust plasma and the quiet vacuum between worlds. By the time you see it, the object has already moved on. Its silence, its steadiness, those are memories too, arriving late but luminous. Maybe that's what makes it so human to study comets. You're always chasing what's already gone, and still you can't look away. You imagine that tiny traveler, now dark, cold, enduring. It doesn't burn, it doesn't flare, but somewhere on its rough surface, ancient carbon grains catch a bit of sunlight and send it homeward. A quiet pulse of brightness that crosses millions of kilometers just to reach your eyes. And when you see it, something in you recognizes the pattern. Not in numbers, but in feeling the sense that everything fleeting carries a fragment of the eternal. What if silence isn't absence, but another way of speaking? What if the universe has languages that burn without flame, that glow without light? Maybe Borisov is just one syllable of that greater conversation, the kind that waits patiently, repeating its message across centuries until someone somewhere listens long enough to understand. Light moves faster than thought, but meaning always takes its time. You sit beneath a dim sky, and the stars above you seem perfectly still. Yet every one of them is in motion, some toward you, some away, all carried by the quiet architecture of gravity. Somewhere in that vast design, Three-Eye Atlas has begun to shine again. Its brightness grows not with the drama of a comet flaring into life, but with the slow insistence of something that refuses to fade. By November, NASA's recorded data placed its magnitude at 9.8, brighter than predicted by almost 1.5 degrees. That number doesn't sound like much, but in astronomy, each step in magnitude means a leap in radiance, Every single digit is a factor of 2.5. That small miscalculation means 3I Atlas is now 2.5 times more luminous than scientists expected. But the light it emits isn't steady. It pulses faintly rhythmically, as if the object is breathing. At the European Southern Observatory in Chile, telescopes captured the pulse across multiple filters: ultraviolet, visible, and near-infrared. The spectrum showed no clear signs of sublimating gas, the vapor trails that should accompany any comet near perihelion. Instead, there was carbon, lots of it. Carbon molecules amorphous and ancient, absorbing blue light and reflecting red. In the lab, this kind of material appears matte and dark, but in the void under direct solar radiation, it glows like ink catching fire. NASA's analysts compared the readings to a class of meteorites called carbonaceous chondrites, primitive rocks that predate Earth itself. They are dense with organic molecules, the same building blocks found in DNA. Pieces of them have fallen across your world for billions of years, seeding oceans with possibility long before the first cell divided. It's strange then to realize that the same chemistry drifting through your bloodstream is also drifting through 3I Atlas right now. You are in a very literal way made of the same dust. From the surface of Earth, 3I Atlas lies against the backdrop of the constellation Virgo. If you trace a line from Spica, the blue giant star that anchors Virgo's hand, you can almost imagine her holding it, a grain of foreign light cupped in her palm. Next to Virgo lies Leo the lion, where another Atlas K1 Atlas glides along its orbit. Astronomers have been watching both. The instruments track their positions in real time through software like Stellarium, fed by data from NASA's JPL Horizons database. For a brief moment in early November, the two comets appear nearly aligned, one glowing gold, one dim gray, mirrored across the border between constellations. To the human eye, the pattern is breathtaking. To science, it's geometry. But the line between them feels almost emotional, as though the universe were holding up a mirror between the known and the unknown. They call this phenomenon conjunction. When two celestial bodies appear close together in the sky, even if they're separated by millions of kilometers, they share the same right ascension, the same place in your field of vision. It's an illusion, but one that carries weight. Every major civilization noticed conjunctions. The Babylonians read them as omens. The Maya built their calendars around them. Today, NASA measures them in arcseconds and orbital parameters, yet the awe remains unchanged. To see two objects align across time and space, two travelers from different origins sharing one patch of sky, is to feel the cosmos whisper, "Look, we are symmetrical for a moment." And symmetry, even brief, is rare in the universe. Astronomers studying 3I Atlas found another symmetry, not in its orbit, but in its heart. When the object was first detected in July, its rotation period was uncertain. By October, through careful photometric observation, they found that its brightness curve repeated every 11.4 hours. That's the length of one full rotation a day on 3I Atlas. Its motion is slow, almost meditative. A world turning once while your own spins 40 times. And yet both rotations trace the same silent rule gravity in perfect dialogue with inertia, each movement balanced by stillness. The mirror between stars, it seems, is not made of light, but of rhythm. NASA's Punch mission, designed to study the outer corona and solar wind, recently released composite images showing 3I Atlas's path through the inner solar system. The probe's detectors caught fine threads of dust and plasma moving in graceful arcs the way smoke curls underwater. No obvious tail, just faint luminescence trailing outward, as if the object were brushing the sunlight aside rather than scattering it. One researcher described it as a comet built to absorb, not reflect. In poetic terms, that makes 3I Atlas a mirror turned inward, a body that remembers light instead of showing it. And maybe that's what makes it feel familiar. Humans too are mirrors. You absorb experiences, thoughts, the light of others. You keep most of it hidden inside until something, a memory, a word, a sound, makes it glow again. If you think of light as conversation, then 3I Atlas is listening more than speaking. It has traveled billions of kilometers through the interstellar medium, crossing clouds of gas that stretch for light years. In that emptiness, it has collected traces of other suns, the residue of supernovae, the ash of dead worlds, the electromagnetic hum of galaxies colliding in the dark. Now it carries all of that into your solar system, quietly reflecting pieces of history that never belonged to you. When you look up and see its brightness curve flattening on a graph, what you're really seeing is the echo of everything it has passed through. There's a story told among astrophysicists, not written, but whispered late at night during observation runs. They say that every comet, every asteroid, every grain of cosmic dust is like a neuron in a larger brain, connected by fields transmitting faint signals across unimaginable distances. If that's true, then maybe 3I, Atlas, and Borisov are not strangers at all. Maybe they are two thoughts from the same mind, traveling toward the same question. And perhaps that mind is not conscious in the way you understand it, but awake in its own vast, quiet way. A living network made of light, gravity, and time. When NASA's data analysts looked at the phase angle, the degree of sunlight reflected toward Earth, they noticed something curious. Despite increasing brightness, 3I Atlas's phase curve was unusually flat, indicating that much of its glow wasn't coming from reflection at all. Instead, it appeared to be emitting faint infrared radiation of its own. That could mean internal heating, a dense metallic core, or more poetically, the afterglow of a journey too long to cool down. Whatever the reason, the comet seems to carry its own warmth, like a lantern that forgot it was once a star. You think about mirrors again, how they never create light, they only return it, and how sometimes even a reflection can reveal more than what is being reflected. Maybe that's what 3I Atlas has become, a cosmic mirror, not to show you what you are, but what you could be, a traveler who moves through fire and darkness, gathering fragments of light without ever losing silence. If you listen carefully, you can almost feel the balance between worlds, the invisible thread that runs from the sun's burning surface through the magnetic storms that paint Earth's skies out past the orbit of Venus, where 3I Atlas drifts in its slow turn. Each is bound by the same physics, the same gravity, the same unspoken symmetry that ties the living to the inanimate. The more you study it, the less it feels like coincidence. It feels like memory repeating itself in form, the universe remembering its own reflection. And perhaps that's why when astronomers stare at this bright, silent traveler, they stop writing equations for a moment. They just look, because even science at its most exact still needs wonder to breathe. Have you ever wondered if the light that finds your eyes tonight has already seen you before, reflected off oceans, clouds, or the quiet mirror of a comet that remembers the same sun? The sun is never still. Even when you close your eyes and feel its warmth across the skin, what reaches you isn't calmness, it's motion. It burns, it breathes, it remembers. Every second, 100 billion tons of hydrogen fuse into helium inside its heart. That fusion releases light heat and energy, a pulse that beats through the fabric of space itself. And every so often, that pulse grows louder. In late October, NASA's Solar Dynamics Observatory began capturing a pattern that felt almost alive. The surface of the sun, wrapped in magnetic filaments, began to twist and tighten. Sunspot region AR3892, one of the largest of the year, rotated directly into view. Across its surface, loops of plasma, each one taller than 10 Earths, stacked together, coiled like living veins of light. Then on October 21st, the pulse changed. An X-1.7 class solar flare erupted from the center of the spot, sending 1 billion tons of charged plasma surging outward at 900 kilometers per second. For minutes, the entire region glowed in ultraviolet and X-rays, a wound of light across the sun's surface. NASA's SOHO spacecraft recorded the explosion as a full halo coronal mass ejection, meaning it was aimed directly at Earth. Within hours, the Parker Solar Probe, then orbiting inside the inner corona, detected the wavefront racing outward. It was the sun's heartbeat made visible. The shockwave reached Earth 2 days later. Sensors aboard the ACE and Discover satellites stationed 1 million miles away at the L1 point recorded the impact, a sudden spike in solar wind density, a compression of Earth's magnetic field, a ripple that circled the planet like an unseen tide. The KP index, a global measure of geomagnetic disturbance, climbed rapidly. From quiet levels near 3, it surged into the G3 range strong storm conditions. Above, the Arctic auroras blossomed like silk curtains made of plasma stretching green and violet across the sky. Even pilots at mid-latitudes over Canada and Europe reported faint ripples of light on the horizon. It was beautiful, but it was also force. When the sun speaks that loudly, every planet listens. NASA and NOAA both track these storms carefully, not only because of their beauty, but because of their reach. Solar flares can interfere with GPS, disrupt radio signals, and in extreme cases overload power grids. The last major event of that scale was the Carrington event of 1859, a flare so powerful it set telegraph wires on fire and painted red auroras across the Caribbean sky. This one, by comparison, was gentle, but the rhythm was changing. The sun's magnetic cycle, an 11-year oscillation, is nearing its peak, known as solar maximum. That means more flares, more storms, and more nights lit by the pulse of a living star. For days after the October event, the sun kept flaring. Smaller bursts, M-class and C-class, followed in sequence like a fading drumbeat. Each one released energy equal to millions of nuclear bombs, yet to the cosmos, it was just breath-steady, natural, inevitable. And through all of it, 3I Atlas and C-2025 V1 Borisov drifted within reach of that expanding field of light. Both objects, already unusual for their brightness and lack of tails, now glowed slightly warmer in infrared measurements. The cause wasn't certain. Some astronomers suggested surface heating from the increased solar flux. Others thought the flare's radiation might have excited reflective minerals on their surfaces, temporarily altering their brightness. Either way, it seemed that even across millions of kilometers, the sun's heartbeat was echoing through them. ESA's Solar and Heliospheric Observatory captured something mesmerizing in those weeks waves of plasma curling outward from the solar disk, twisting through the corona like ripples across an ocean of fire. The movement was rhythmic, a visible cadence of expansion and collapse, each one sending shock waves through the heliosphere. Physicists call these oscillations coronal waves. To them, it's magnetohydrodynamics plasma responding to invisible magnetic strings. But to you, it feels simpler. It feels like breathing. Because that's what the sun does, inhale and exhale, but on a scale of stars. On Earth, that breath changes the very air around you. High above the atmosphere, charged particles stream along magnetic field lines and collide with oxygen and nitrogen atoms. When they do, they release photons, the shimmering green and red curtains you call the aurora. But those lights are only the visible part. The same storms also generate geomagnetically induced currents that flow through the crust, through pipelines, and through power networks. Seismologists have long noted that during strong solar storms, certain regions of Earth's crust record slight electromagnetic fluctuations. Nothing catastrophic, but enough to remind you that your planet, too, is part of this pulse. Every quake, every flicker of lightning, every shimmer of the aurora, all are notes in the same unseen symphony. At NASA's Goddard Space Flight Center, researchers studying the sun's polar fields noticed something subtle. During this cycle, the northern and southern magnetic poles of the sun are reversing faster than expected. It happens every 11 years when magnetic lines twist and collapse into new configurations. For a brief time, the poles cancel out, leaving the sun's magnetic field weaker but more chaotic. That's when flares multiply and the solar wind roars the loudest. Right now in 2025, we are near that turning point. The sun is literally flipping its heartbeat. You imagine it. A vast sphere of nuclear fire spinning, folding its fields, preparing to begin again. And far away on a small blue world, covered in oceans and breath, every compass needle trembles just slightly. Tiny particles that left the sun's surface minutes ago are now raining down into your upper atmosphere, guided by invisible lines of force that curve gracefully toward the poles. It's humbling knowing that even your heartbeat in some quiet way follows the same rhythm. The average human heart beats once every second. The sun's magnetic heart beats once every 11 years. Two patterns different in scale, identical in purpose, keeping order in the chaos of energy. From the window of a distant observatory in Spain, an astronomer captures a faint image of Three-Eye Atlas shimmering against the stars. She notes something odd, the object's coma. The hazy halo of light surrounding it has elongated slightly, stretching away from the sun as though tugged by invisible wind. It isn't a tail, not really, just a breath. A small acknowledgement that it too feels the sun's pulse. The sun's power is not violent by nature, it's generous. Every ray that reaches Earth feeds the chemistry of life. Plants turn it into sugar, your skin turns it into warmth, and telescopes turn it into knowledge. Without it, you wouldn't just freeze, you'd vanish from memory. So perhaps the flares, the storms, the surges are not warnings. They are reminders that even the most stable light in your life has its moods, and that in those moments of chaos, something beautiful always follows auroras, data, understanding, awe. Late at night, long after the storm has passed, the sun continues its quiet burn. Photons leave its surface, crossing the darkness in waves that never touch, but never separate. 8 minutes later, they arrive here at the edge of your world, brushing against the atmosphere, scattering into color. That light is ancient by the time it reaches you, but still new enough to make a shadow. You lift your hand, and for a moment you hold the proof of everything. The warmth of a star 150 million kilometers away, touching a single skin cell with perfect accuracy. How could something so distant know you so precisely? You are drifting again. Not through silence, but through a field of invisible lines. They stretch from the sun like strands of lightless silk, unseen, untouchable, yet holding the entire solar system together. Scientists call them magnetic field lines. They arc and twist, shaping the solar wind, bending it into spirals that wrap around every planet. The Parker Solar Probe, now the closest human-made object to ever touch the sun, moves through those threads, each one humming with electrical tension. The spacecraft's instruments have recorded the faint hiss of charged particles streaming by billions of protons, dancing to the pulse of a magnetic drumbeat. And still you can't see it. The sky looks empty. But in truth, you are living inside an ocean of magnetism. The Earth itself has its own invisible cocoon, the magnetosphere. It stretches far beyond the clouds, a teardrop of energy that shields your planet from the fury of the solar wind. When the sun erupts, the wave of plasma rushes outward, colliding with that shield, compressing it, making it sing. Sometimes the song becomes visible green ribbons over the poles, the auroras that flicker like breath against the upper atmosphere. Each one is a collision made visible, a cosmic handshake between the sun and the earth. The aurora is not just light. It's data translated into beauty. Every shimmer marks a stream of electrons spiraling down magnetic field lines at near relativistic speeds, colliding with oxygen and nitrogen high above you. When oxygen glows green, it means energy is being released at around 557 nanometers a wavelength that the human eye sees as the color of renewal. When nitrogen glows violet, it means the energy is higher still, the atmosphere trembling under cosmic pressure. And you are part of that same network. Every heartbeat, every signal in your brain depends on electricity moving through ions and membranes, tiny versions of those same forces that travel from the sun to Earth. In the smallest scale and the largest energy is always finding a way to move. Far beyond the aurora's space itself isn't truly silent. It's filled with magnetic whispers called Alfvén waves, rippling through plasma like sound through water. NASA's Parker Solar Probe detected them as rhythmic fluctuations waves carrying momentum outward. Sometimes they reverse direction as if the sun is breathing, inhaling and exhaling streams of charged particles. Magnetic fields don't exist alone. They twist together, reconnect, and burst. That reconnection releases enormous energy, the reason why solar flares happen, why coronal mass ejections can fling billions of tons of plasma into space. It's the same principle that powers lightning on Earth scaled to stellar size. Imagine that an invisible knot forming in the fabric of magnetism, then snapping. The release is so powerful it can be detected across millions of kilometers, and yet it happens without sound. Astronomers have learned to see these invisible threads through instruments tuned to extreme ultraviolet light. Where you see darkness, telescopes see waves of 171, 193, and 211 angstroms, each one mapping the temperature of the sun's corona. The hottest regions glow in ghostly blue, 1,000,000 degrees hotter than the surface itself. Scientists still debate why the corona is so hot, how the outer atmosphere of the sun burns at more than 1,000,000 Kelvin, while the photosphere beneath it sits at just 5,800. The leading theory is something called magnetic heating, tiny constant reconnections between magnetic field lines, each one releasing bursts of energy like microscopic lightning. It happens everywhere, all the time, a background hum of creation that never ends. It means that even in calm, the sun is alive. Even in stillness, it breathes. At night, if you could see magnetic fields, the sky would look nothing like what you know. You would see glowing ropes connecting stars, massive currents linking nebulae across parsecs of vacuum. Our galaxy, too, is laced with magnetism, a spiral of invisible order. The Milky Way's field is weak by human standards, only a few microgauss 1,000 times weaker than a fridge magnet, and yet it shapes entire clouds of gas guiding the birth of stars. When those clouds collapse, the field lines twist and amplify, seeding newborn suns with the same spinning magnetic heritage. It's almost poetic that every star, every world, even your own heart begins with something you cannot see. Sometimes I wonder what it would feel like to drift through that magnetic ocean, to sense the lines the way birds do. Migratory species can detect the Earth's field. They navigate through invisible maps written across the air. Perhaps they feel what we only calculate, the silent geometry of space, the way energy bends, the way it flows. Would you want to see it too? Would you want to live in a world where light itself revealed the hidden architecture of every force around you? If you could, the night sky would no longer be black. It would shimmer with rivers of magnetism, faint as breath, strong as gravity. The Parker Solar Probe once flew so close to the Sun that it entered the Alphen critical surface, the point where the solar wind stops being bound to the Sun and becomes free. It was the first time humanity ever touched a star. And yet even there, the magnetic fields reached out, invisible threads, still linking the probe back to home, back to Earth. When NASA's scientists described that moment, they didn't speak of danger or heat. They spoke of quiet. Inside the corona, the sun's magnetic structure became ordered, symmetrical, almost serene. It's as if the closer you come to chaos, the more harmony you find at its heart. Every magnetic field in the universe loops back on itself. It never truly ends, it only changes form. Energy leaves the sun as wind reaches Earth, flows into the magnetosphere, then into you, then radiates back as warmth, light, movement, thought. Nothing is ever lost. It only transforms, whispering across scales too vast for the eye to see. And maybe that's the quiet truth of the universe, that all the chaos you see is really just an intricate balance woven together by invisible threads. You open your eyes somewhere beyond sound. There is no wind, no ocean, no horizon, only light in motion. At first, it seems like chaos, a storm made of brightness and silence. But look closer. Every storm, even in space, speaks a language. On the sunstorms, don't have thunder. They speak through magnetism and plasma, through arcs of charged particles that rise and fall in patterns too vast for a human eye to grasp. When scientists observe a solar flare, what they're really hearing is a sudden rearrangement of the magnetic field, a tension built up over days, then released in seconds. A typical flare can unleash energy equivalent to 10 million volcanic eruptions all at once. X-class flares, the strongest of them all, can accelerate particles close to the speed of light, and yet if you could stand near one, you would hear nothing. No boom, no roar, just light itself carrying messages across empty space. When these solar storms travel outward, they ride the solar wind, moving through the heliosphere like invisible waves of pressure. At their fastest, they reach Earth in less than 2 days, a pulse from the sun's heart, arriving at your magnetic doorstep. The Parker Solar Probe and NASA's SOHO and DSCOVR satellites measure those pulses every hour. They watch for coronal mass ejections, the vast clouds of plasma that expand millions of kilometers wide. When such a wave hits the Earth's magnetic field, it bends, trembles, and releases its own response, the shimmering auroras, the curtains of light that ripple across the poles. If the impact is strong enough, power grids hum, satellites drift, radio signals waver. The storms that start in the heart of the sun can whisper in our wires. The sun has been speaking this way for billions of years. Its rotation drags the magnetic field into great spirals called the Parker Spiral, wrapping the solar system in a subtle electromagnetic geometry. Every planet, every comet, every interstellar traveler moves through that invisible pattern. Even 3I Atlas, now drifting away into the cold, still carries traces of the sun's breath upon its rocky surface, a thin layer of charged dust that remembers where it came from. Scientists describe this constant motion as space weather, a living, breathing current of plasma and radiation that never stops flowing. But the term weather feels almost too small for what it is. This isn't mere turbulence, it's communication, a conversation between the sun and everything that orbits it. When solar storms strike, they create geomagnetic substorms, bursts of energy that pulse through the ionosphere like a heartbeat. Earth's magnetic field begins to oscillate, shifting currents in the upper atmosphere. Auroral arcs brighten, then fade, then brighten again. The rhythm is precise waves that repeat every few minutes, forming patterns known as PC5 pulsations. It is in a way the Earth's own reply to the sun, a call and response written in electromagnetic waves. The European Space Agency's cluster mission once flew through these storms, measuring the oscillations in real time. What they found was astonishing. The waves were musical. Their frequencies could be translated into sound, deep hums, rising tones, soft echoes that resemble the ocean's tide. When played through speakers, they sounded almost alive. And perhaps they are. Imagine for a moment that you could hear that music directly. You're floating above the polar caps, the atmosphere glowing green beneath you. Below the Earth's magnetic field quivers each pulse echoing through the thin air. Above the solar wind hums like a choir of photons. You are not hearing separate sounds, but a single harmony, the voice of a star and the planet that listens. Even the quiet between storms has a pulse. During solar minimum, when the sun's surface grows calm and sunspots disappear, its wind slows down. The magnetic field weakens, and cosmic rays, high-energy particles from beyond the galaxy, drift in more freely. It's a strange trade. When the sun rests, the universe speaks louder. Astronomers call this balance the 11-year solar cycle. Right now, as you breathe, the sun is climbing toward its next peak solar maximum expected in 2025-2026. Sunspots multiply, magnetic loops grow taller, flares more frequent. It's as if the star is waking from a long dream, stretching, crackling, and warming its vast magnetic limbs. But this awakening isn't violent. It's rhythmic, predictable, almost gentle in its inevitability. The same way a tide returns to shore, the sun's energy returns in cycles. Every pulse of light, every flare, every solar storm is part of a heartbeat that's been steady for 4.6 billion years. You exist inside that rhythm. Every electron in your body has felt it, the faint fluctuations of solar radiation that define the boundaries of life. Your planet's climate, its magnetic shield, even the auroras that crown the poles, all move to that same silent measure. The storms aren't random. They are part of the sun's language, the oldest form of communication in the solar system. Sometimes scientists forget the poetry in their data. They speak of plasma density, of electron temperature, of ion flux, but beneath those numbers lies something ancient, a star trying to keep balance with its children. And maybe that's all storms really are: not chaos, not destruction, but the universe reminding itself that it's alive. Because even the fiercest flare begins with stillness. Even the most powerful magnetic reconnection begins with tension and release, like breath, like a heartbeat, like a song you can't quite hear but somehow know by memory. You drift again through that luminous sea. Around you, magnetic spirals fade into night. You feel the hum of plasma currents stretching far beyond the horizon. And somewhere in that silence, you begin to understand the storms were never noise. They were the voice of order itself. You drift through a silence that feels almost solid. No storms, no flares, no rushing solar wind, only stillness. And yet beneath that stillness, something is building. An invisible geometry, patient and precise. The universe, it seems, never truly rests. It only pauses to design. Far below, deep inside the sun, the real architects are at work, neutrinos born in nuclear fusion reactions, racing outward from the core. Each second, more than 108 neutrinos pass through every square centimeter of your body, and you never feel them. They move through the densest matter as if it were air. They are the silent witnesses of creation, carrying information from the heart of the star that made them. The fusion that creates them is ancient and elegant. Hydrogen atoms crushed by gravity merge to form helium in a process called the proton-proton chain. Every second, the sun transforms about 600 million tons of hydrogen into 596 million tons of helium, the missing 4 million tons. They become light. They become warmth. They become the energy that paints your sky blue and lets oceans breathe. And that is how quiet power moves, not through force, but through transformation. It takes light about 8 minutes to reach Earth, but before that, it takes thousands of years just to escape the sun's interior. A single photon begins its life in the sun's core, bouncing from particle to particle in what scientists call a random walk. It can take 10,000 to 100,000 years for that photon to finally break free into space. By the time it reaches your skin, that light is ancient, a memory of a moment that happened long before human history began. You look up and it feels immediate, but you are being touched by time itself. Astronomers once thought of light as a wave. Then they found it was also a particle. Then they learned that its behavior depends on how you look at it. Photons bend when space bends, stretch when the universe expands, vanish into black holes, yet still leave a trace. Every photon carries information, a note from the universe, written in frequency and wavelength. When NASA's Solar Dynamics Observatory studies the sun, it listens to those notes in multiple wavelengths, at once ultraviolet, X-ray visible light. Each one reveals a different layer of the solar symphony, the photosphere, chromosphere, and corona, all playing together in radiant harmony. Light isn't just brightness, it's structure, it's order emerging from fire. Out here, the sun seems solitary, but it's not alone. All around it, particles drift, remnants of past collisions, ancient comets, fragments of forgotten worlds. The solar wind carries them outward, wrapping the heliosphere in a magnetic cocoon that stretches nearly 100 astronomical units, almost to the edge of the Voyager spacecrafts. Those probes, now traveling through interstellar space, still detect faint whispers of the sun's presence, the density of plasma, the slow pulse of magnetic field lines, the echo of home carried across the void. You exist inside that structure, a cathedral of invisible architecture where gravity sculpts, magnetism weaves, and light fills every corridor. You are not outside the universe looking in. You are a part of its design. Every so often, the sun releases not just flares, but patterns, cycles of magnetism that reverse polarity every 11 years. This grand alternation is part of the Hale cycle, a longer rhythm that resets the sun's magnetic heart. North becomes south, south becomes north. It's a solar heartbeat flipping every 2 decades, invisible yet foundational. Earth, too, listens to that pulse. When the sun's polarity flips, the planet's upper atmosphere shifts. Radiation levels fluctuate. Auroras brighten. Even cosmic rays, the high-energy travelers from distant galaxies, are deflected differently depending on that magnetic orientation. And through all of this, your planet moves like a seed carried by the wind, shaped by a force you can't touch but always feel. Sometimes, when astronomers map the magnetic field of the sun, they color it in blue and red to show opposite polarities. But in truth, there is no color there, only energy, only structure. It's the universe sketching itself in visible hands, drawing lines no artist could ever complete. If you could see it, it would look like threads of gold weaving through a sphere of flame, a tapestry constantly unmade and remade. NASA's Parker Solar Probe has flown through those threads, its sensors brushing the edge of plasma filaments. Inside the corona, Parker recorded bursts of particles moving back toward the sun, a sign that the solar wind doesn't only flow outward, it breathes in too. For every exhalation of plasma, there is an inhalation, a pull of particles returning, caught by gravity and magnetic loops. The sun, it seems, is not exploding. It's exhaling and inhaling in slow cosmic rhythm, just as you do. You may not feel it now, but your every breath, every beat of your heart echoes that rhythm. The same balance of expansion and contraction, the same quiet architecture. It's everywhere, from the movement of galaxies to the spin of electrons. Every atom is a small model of motion and symmetry. Even chaos has rules. You might think you are small, but the same patterns that guide the sun also shape you. The same light that left the core of a star 100,000 years ago is now reflected in your eyes. Perhaps that's what scientists mean when they call this universe self-organizing. It's not just physics, it's patience, it's design that never hurries but always continues. And maybe, just maybe, you are one of its quiet architects too. You drift again, weightless and unhurried. The storms have faded, the architecture is complete. Now what remains is light. Old light, patient light, still traveling across the quiet corridors of space. Everywhere you look, light remembers. It carries the memory of every collision, every birth, every death that ever occurred in the universe. Not a single photon is wasted. Not one truly disappears. They scatter, bend, and stretch, but the story they tell never ends. Some of the light that touches your skin tonight left its source billions of years ago. Photons from distant galaxies have crossed the expanding universe, their wavelengths stretched by time itself, a process scientists call cosmological redshift. The farther away a galaxy lies, the more its light is stretched. It is as if the universe itself is exhaling, and light is the breath that carries its memory outward. When astronomers look through the James Webb Space Telescope, they are not just observing distance, they are observing the past. Each red glow captured by its infrared mirrors is a time capsule light that began its journey when the first stars were still forming from hydrogen fog. Those ancient stars, known as Population 3 stars, burned hotter than any that exist today. They were enormous, unstable, and short-lived. When they died, they forged the first heavy elements, carbon, oxygen, iron, the very atoms that now live in you. So the light you see is also your ancestry. Every shimmer in the night is a reflection of what built you. NASA once described the cosmic background radiation as the oldest light in the universe. Discovered in 1965 by Penzias and Wilson, it fills every direction faint and uniform at a temperature of about 2.725 Kelvin. This is the afterglow of the Big Bang, not an explosion, but an expansion the moment space itself began to stretch and cool. The photons from that moment have been traveling for 13.8 billion years, slowing, cooling, fading. What was once white-hot plasma now glows in microwaves detectable only by sensitive instruments like Planck or WMAP. To the human eye, it's invisible, but to physics, it's everything. Those waves contain the fingerprints of structure, the seeds of galaxies, the blueprint of cosmic gravity, the faint echo of where it all began. And somewhere inside that invisible hum, your existence was already written. Every time you open your eyes, you add another layer to the memory of light. Your pupils absorb ancient photons, triggering chemical reactions in the cells of your retina. Those signals move through your neurons at the speed of thought, turning energy into meaning. You see not only what is in front of you, but what once was light as memory translated into vision. Even now, photons from the sun that struck the moon are bouncing back toward you. Some travel from ice fields on Mars, some from the faint rings of Jupiter. A few, perhaps, from the thin tails of comets, scattered dust glowing in reflected sunlight. Light links every world to every other. It is the bridge across which time flows. The physicist Max Planck once wrote, "Matter is only a form of energy that is slowed down enough to be seen." It means that everything solid, everything you can touch, was once light slowed into form, energy folded into structure. The stars are not so different from you. They burn and transform. You breathe and transform. Both radiate, both remember. The Voyager 1 spacecraft, now over 24 billion kilometers from Earth, still sends back faint radio light, a whisper, encoded in electromagnetic waves traveling more than 22 hours before reaching us. That signal, too, becomes part of the cosmic memory. Even the machines we make contribute to the song of photons. Astronomers often speak of the interstellar medium, the thin dust and gas that fills the space between stars. It is almost empty by human standards, yet even there, light persists. Photons scatter off tiny grains of carbon and silicate, creating faint reflections called zodiacal light. It's that ghostly triangle you sometimes see before dawn when sunlight reflects off cosmic dust near Earth's orbit. If you've ever seen it, you were looking at a mirror made of time light that left the sun minutes ago, touching dust billions of years old. And still the memory travels. Scientists have found that when galaxies collide, their stars rarely crash directly. Instead, their light merges, forming long streams of stars known as tidal tails. Those trails shine faintly like scars of memory left behind by gravitational encounters. Sometimes in these regions, new stars are born light, giving birth to more light. There is no violence here, only transformation. Even destruction becomes a form of creation. The Hubble Ultra Deep Field, that tiny patch of sky, less than 1/10 millionth of the total, revealed over 10,000 galaxies each, filled with billions of stars. Most of them will never see each other, and yet they share one canvas. They share the same light. You exist in that same exchange. Every surface you touch reflects photons outward. Every motion you make changes how light moves around you. You are written into the universe's photograph, not metaphorically, but physically. Quantum physics teaches that every interaction between light and matter leaves a trace. Somewhere in the vast data of the cosmos, your reflection has already joined the record. Light remembers everything it touches, and that means it remembers you. In the quiet of night, when your eyes close, you're not leaving light behind. You're simply letting it pass through. Your body continues to emit infrared radiation, your own small signature of warmth, flowing invisibly into the surrounding dark. That warmth travels outward forever. Even your stillness becomes part of the story of energy. The next morning, when sunlight returns, it finds you again, not as something separate, but as something it has always known. Every sunrise is a reunion between memory and matter, and perhaps when light reaches its farthest edge and fades into something beyond sight, it will not vanish, but rest carrying every color, every glimmer, every moment it ever touched into the quiet where beginnings and endings no longer matter. You live inside a clock you can't see. Every second that passes isn't just measured by numbers, it's measured by light, the rise and fall of the sun, the quiet pulse of your heartbeat, the rotation of a world you never feel moving. You are time's passenger, but also its keeper. Inside you, there's a rhythm not made of gears, but of cells. They tick and hum in quiet harmony, guided by something older than any machine, the circadian rhythm, your inner day. It's more than a pattern of sleep and waking. It's a conversation between your body and the cosmos, the earth spinning beneath you, the sun tracing arcs of light above. Every cell in you carries a clock. Inside their nuclei, genes like clock BMAL1 and Cry keep time with astonishing precision. They switch on and off in cycles that last about 24 hours, orchestrating when hormones rise, when temperature dips, when energy flows. You are not just moving through time. Time is moving through you. NASA once discovered that even astronauts orbiting far above Earth in microgravity with no sunrise, no sunset, still kept the rhythm. Their circadian cycles persisted as if the body remembers light even in its absence. But over time, small disruptions appeared: sleep fragmentation, slower reaction, emotional drift. Without the natural dance of daylight and darkness, the body begins to forget where it belongs. That's why the International Space Station follows an artificial dawn and dusk lamps that mimic Earth's sunrise to keep its crew synchronized with the planet below. It's not just comfort, it's survival. Because even silence has timing, even darkness has memory. You might think sleep is an escape, a kind of oblivion, but sleep is the body's great repair, the quiet miracle that turns exhaustion into order. In the first hours, your brain enters slow-wave sleep when neurons pulse in unison like a slow tide. This is when your cells clear debris through a process called the glymphatic system, flushing waste proteins from between brain cells, including beta amyloid, the molecule linked to Alzheimer's disease. It happens mostly when you sleep, never when you're awake. It's as if time waits for you to rest before it cleans its own house. Deeper into the night, dreams appear, the fragile, colorful theater of REM sleep. Scientists once thought dreams were meaningless noise, but now they know REM sleep is when the brain reorganizes memory-blending fragments into meaning-storing patterns, softening pain. It's when emotional wounds are replayed and rewritten, when the mind rebalances itself quietly without you ever knowing. That's why you sometimes wake lighter, even if nothing around you has changed. Your brain, in its own secret language, has been healing all night. Time isn't a straight line here. Inside your body, it loops, repairing, resetting, returning. The heart slows, blood pressure lowers, cells divide more efficiently, DNA repairs its small fractures caused by sunlight and stress. Every night, billions of tiny errors in your genetic code are corrected by molecular caretakers. They are enzymes like PARP1 and DNA polymerase guardians working in the dark. And when dawn comes, those same cells wake again, clean, renewed, ready to begin the cycle anew. It happens every night. You just have to let time do its work. The light that wakes you each morning isn't merely brightness, it's a message. The first photons striking your retina activate melanopsin, signaling your brain's suprachiasmatic nucleus, the master clock hidden deep within the hypothalamus. This single cluster of neurons tells your entire body that day has begun. Cortisol rises gently, metabolism awakens, temperature increases. You are tuned once more to the sun. Without that morning light, your rhythm drifts. Days blur, nights lose their edges, time unravels. That's why sunlight feels like healing, because it literally resets the mind's compass. There's something poetic about the fact that your body's rhythm mirrors the planet's. The Earth rotates once every 23 hours, 56 minutes, and 4 seconds. Your biological clock, 24 hours and a breath. Close enough to stay in step, different enough to remind you that even time itself has imperfections. The moon, too, adds its signature. Its 29.5-day cycle tugs not only on oceans, but on hormones, sleep phases, even the birth patterns of certain species. You are a creature of tidal light, shaped by orbits you'll never touch. Time heals because it repeats, not as punishment, but as rhythm. The cycles of your body, heartbeats, breaths, days, years, are echoes of a larger cosmic order. The sun burns hydrogen to helium in 11-year waves of magnetism. The earth tilts through its seasons. Your heart beats once per second, your breath every few. All of it, one great metronome of existence. And yet time is gentle. It doesn't rush you. Even your scars fade with it molecule by molecule. Even your memories change shape under its light. That's not forgetting. That's rebalancing the physics of mercy. Deep in your brain behind the eyes sits a pine cone-shaped organ, the pineal gland. When darkness falls, it releases melatonin, a hormone that whispers to every cell, it's time to rest. Melatonin doesn't make you sleep. It tells your body when to sleep. It synchronizes the orchestra, preparing every system for renewal. And then slowly, the world dims. Your temperature lowers. Your mind softens its focus. You drift not away, but inward, into the slow breathing rhythm that connects every living thing that has ever rested. Even stars rest. When their cores run out of hydrogen, they expand cool and pause before collapse. Even the cosmos sleeps between its own creations. You have been told that time is linear, that it moves forward and never returns. But inside you, time folds. Every sleep, every heartbeat, every morning light is a small circle, a reminder that healing doesn't happen once, but always. The rhythm of repair never ends. It just changes tempo. Tonight, as you drift into that rhythm again, you are not escaping time, you are joining it. You are the proof that time itself knows how to heal. You are not the same person you were yesterday, not entirely. Inside your skull, something has shifted quietly, invisibly. Connections have been rewritten, paths, reformed, memories softened and reshaped. You are always becoming. Every thought you have leaves a trace. Every moment of learning, of fear, of love, it carves a mark across your brain's architecture. Neuroscientists call this neuroplasticity, the brain's ability to change itself. It's not metaphor, it's physics in flesh. Microscopic rivers of ions flow through neurons, strengthening some bridges, pruning others, sculpting the landscape of you. At birth, your brain is a wild forest, nearly 100 billion neurons, each capable of connecting to thousands of others. As you grow, the forest trims itself. Unused connections fade. Frequently used ones grow stronger, their myelin sheaths thickening, allowing electrical impulses to move faster up to 120 meters per second. That's faster than a racing car traveling inside you. And all of it happens in silence. No noise, no spark, just the soft hum of living electricity. When you learn something new, a language, a melody, a habit, what you are truly doing is reshaping your own wiring. Synapses release neurotransmitters, glutamate for excitation, GABA for calm, dopamine for reward. The chemical ballet repeats, stabilizes, and eventually builds a bridge. That bridge becomes a memory, a pattern, a new version of you. Sleep completes the construction. During slow-wave sleep, the brain replays recent experiences in miniature, compressing, editing, and storing them into long-term memory. In this replay, the hippocampus whispers to the neocortex, transferring short-term sparks into stable networks. It's as if your mind spends the night rebuilding itself from fragments of yesterday. Even damage doesn't end the story. In 1917, scientists believed the adult brain was fixed, unchangeable once matured. But by the 1960s, evidence began to shift. Researchers like Paul Bocchi-Rita showed that stroke patients could relearn lost abilities by rewiring undamaged parts of the brain. Neurons adapt, recruit neighbors, find new routes around broken circuits. Today, brain imaging confirms it. After trauma, entire regions reorganize within weeks. The brain isn't static, it's fluid. It survives by changing. Even in ordinary life, that same principle quietly sustains you. Each time you break a habit, comfort a fear, or imagine a future, your brain redraws its own map. Neuroplasticity is not just survival, it's growth written in biology. Your prefrontal cortex learns balance between impulse and reason. Your amygdala, once overactive from fear, can calm with repeated safety. Your anterior cingulate cortex mediates empathy, learning to resonate with others through experience. It's not that emotions change your mind. Emotions are your mind reshaping the very tissue that holds your identity. You aren't trapped by who you were. Your neurons are literally learning how to forgive. When neuroscientists record electrical patterns from living brains, they find something beautiful. In the midst of chaos, order emerges. Neurons fire in waves synchronized like ocean tides. Even during rest, your brain isn't still. It drifts through patterns called the default mode network, wandering through memory, imagination, and self-reflection. That wandering is not waste, it's maintenance, a way your mind keeps its pathways flexible, reconnecting the past to the possible. Daydreaming is not idleness, it's quiet architecture. Deep within glial cells, once thought to be passive, now reveal their importance. Astrocytes regulate blood flow and nutrient delivery. Microglia patrol like silent custodians, pruning excess synapses, cleaning debris. At night, the glymphatic system expands, washing cerebrospinal fluid through brain tissue, removing toxins and resetting chemical balance. Each night's rest is not retreat, it's repair. Every dream is a renovation. You sleep and your brain rebuilds itself molecule by molecule. Even memory, fragile, shifting, is not stored in one place. It's distributed, a constellation of neurons lighting up in patterns of experience. That's why memory is never perfect. It's not a recording. It's a recreation, the brain rebuilding the moment anew each time you recall it. And so remembering changes you again. Every recollection is an edit. Every thought about who you were rewrites who you are. In the labs of MIT, Stanford, and Kyoto, researchers now use optogenetics shining light on specific neurons to trigger memories or suppress fear. They found that even fear memories can be overwritten with safety signals changing behavior without words. Hope, it turns out, can be engineered. But even without lasers, you do it daily. Each time you choose calm over panic, reflection over reaction, compassion over anger, you teach your neurons a new rhythm. And slowly, quietly, they learn. It's strange to think that consciousness, this endless stream of feeling, thought, and awareness, is the result of coordinated electrical patterns inside 1.5 kilograms of living tissue. But it is. The spark of curiosity, the ache of love, the peace before sleep, they are the brain speaking in light. Every idea you've ever had was once a flicker between two neurons, every dream a whisper of electricity. And yet somehow the sum of all those signals becomes something vast, a mind that can imagine stars, question existence, and find meaning in silence. If the universe builds galaxies from gravity and plasma, then the brain builds universes from memory and thought. One expands outward, the other inward, but both obey the same laws of connection, emergence, and flow. Neuroscientists sometimes call this self-organized criticality systems that hover perfectly between order and chaos, like the edge of a wave before it breaks. Your mind lives there too, always on the border of change, always building itself anew. And perhaps that is what consciousness really is, not a fixed thing, but a process, a flame that keeps rewriting its own shape. When you lie down tonight, your neurons will begin again. They will replay the day, reinforce the bridges that matter, release what doesn't. Your brain will shrink slightly, allowing cerebrospinal fluid to flow more freely. You will drift through REM cycles, each one longer and deeper than the last. And by morning, you'll be subtly different. No miracle, no magic, just biology at its most patient and poetic. You are a mind that heals itself through remembering, a being that learns by dreaming, a consciousness that keeps changing because it must. You are not static, you are neuroplastic. And that means you are alive in the truest way possible, never finished, always becoming. You are not alone in your own body. Every inch of you, every breath, every heartbeat is shared. Inside you lives a civilization so vast, so ancient, that it rivals the stars in number. They are invisible, yet they build, protect, and transform you every moment you exist. They are your microbiome, the trillions of bacteria, fungi, and viruses that live in symbiosis with you. Scientists estimate that your body hosts about 39 trillion microbial cells, slightly more than the number of your human cells. For every step you take, every word you whisper, there is an invisible community walking with you. They line your skin, dwell in your lungs, and most of all flourish within your gut, a world of its own where 1,000 species cooperate like stars in a silent galaxy. Under a microscope, it's astonishing, an entire cosmos made of motion, color, and rhythm. Tiny organisms swim through nutrient rivers, forming colonies, sharing messages through chemical signals called quorum sensing. They speak in the language of molecules, deciding together when to grow, when to rest, when to help, and when to defend. It's a democracy of the unseen. In the darkness of your intestines, where no light ever enters, these microbes break down food, synthesize vitamins, and train your immune system to distinguish friend from foe. Without them, you couldn't digest fiber, produce vitamin K, or absorb key fatty acids. Without them, you would be far more fragile. When you eat, you're not feeding just yourself. You're feeding an ecosystem. Fiber from plants becomes fuel for bacteria like Faecalibacterium prausnitzii and Bifidobacteria, which in turn produce short-chain fatty acids molecules that reduce inflammation, strengthen the intestinal wall, and even influence your mood through chemical messengers like serotonin and GABA. Yes, your microbes talk to your mind. Through the gut-brain axis, they send signals via the vagus nerve, shaping how you feel, how you sleep, how you dream. You are not just one consciousness. You are a choir of many. Scientists once believed the brain was in command, but new research shows that your gut can speak back, whispering to your neurons through metabolites, hormones, and electric impulses. Over 90% of the body's serotonin, the molecule of calm and happiness, is produced in the gut. Your inner world shapes your outer peace. When you're anxious, the gut tightens. When you're calm, it relaxes. When you rest, it rebuilds. It's not just biology, it's a conversation. Every person carries a unique microbiome like a fingerprint made of life. Some microbes arrive from your mother during birth, some from the food you eat, some from the air you breathe. You are not born alone, you are born shared. A study from the Human Microbiome Project revealed that these communities shift with every meal, every stress, every season. They evolve with you, responding to your choices with remarkable intelligence. If you nourish them with whole foods, plants rest, and sunlight, they flourish. If you neglect them with antibiotics, stress, or isolation, they fade. And when they fade, the balance within you trembles. Autoimmune diseases, allergies, depression, and even neurodegenerative conditions have been linked to disruptions in this hidden ecosystem. But the opposite is also true. Healing begins not just in the mind, but in the microbial stars within you. Imagine your gut lining is a galaxy wall. Your bacteria, its stars, spin and orbit in harmony. Every one of them shines a purpose. Some protect against inflammation, some digest sugars, some regulate sleep. Together, they form the biochemical night sky that sustains your health. When you drink fermented milk or eat a piece of sourdough, you're inviting new constellations into that sky: Lactobacillus, Streptococcus, Saccharomyces, all ancient travelers who've lived beside humankind since before history. They are older than language, older than art. You are their latest canvas. Even in death, they continue. When your body cools, your microbes don't vanish. They begin one final transformation, decomposing, recycling, giving your atoms back to Earth. In a strange and sacred way, they are the guardians of continuity. They return you to the soil, and the soil to life. NASA scientists studying long-duration missions to Mars have found that maintaining a healthy microbiome in astronauts is essential. In microgravity, certain bacteria multiply faster, while others weaken, changing immunity and metabolism. The Human Microbe Alliance, it seems, is universal even among the stars. Wherever humans go, this invisible civilization follows. And perhaps that's the most beautiful truth of all. You are not a single organism, you are an ecosystem, a moving world of balance and cooperation. When you breathe, trillions breathe with you. When you sleep, they repair you. When you wake, they awaken too. The miracle of the microbiome is not that it exists, it's that it reminds you that wholeness comes from connection. You are a galaxy pretending to be a single star. Tonight, as you rest, your microbes will work quietly in their unseen cities. They will clean, digest, repair, and communicate. Their tiny chemical songs will keep your heart steady, your immune system calm, your dreams balanced. And when morning arrives, you'll rise carrying their quiet legacy inside you, a living chorus of life that never sleeps. You are never alone. You are a constellation made of cells, and among them, billions of voices whispering one eternal promise. We are here, we are healing, we are you. You live on a breathing planet. It inhales and exhales, though you cannot hear it. Its pulse moves through oceans, its rhythm hums beneath mountains. It has a heartbeat, faint, slow, steady one that never stops. And though you may not notice, it carries you with every beat. Scientists call it the Schumann resonance, the natural electromagnetic frequency that vibrates in the cavity between Earth's surface and the ionosphere. Every lightning strike, every solar wind ripple, every geomagnetic whisper keeps it alive. It pulses mostly around 7.83 Hertz, a low, inaudible tone that travels around the globe, continuously circling the planet 8 times per second. If your ears could hear it, it would sound like the softest hum, a note too deep to touch, a voice too slow to age. It is, in a way, Earth's own heartbeat. Researchers at NASA have been recording this resonance for decades. They found that it can rise and fall depending on solar activity, geomagnetic storms, and even global weather patterns. When lightning flashes somewhere in the tropics, its electromagnetic wave joins the song, adding another breath to the planet's rhythm. Some scientists even suggest that this resonance interacts with your own biology. Your brain's alpha waves, those generated during calm focus or meditation, often vibrate near the same range between 8 and 12 Hertz. Perhaps that's why standing barefoot on grass or listening to thunder sometimes feels like alignment. It's not mysticism. It's resonance physics meeting physiology. Beneath your feet, the planet has another kind of pulse, seismic, deep, and slow. The core of the Earth spins faster than the surface by a small fraction, generating the geomagnetic field that protects all life from solar radiation. This invisible shield, stretching far into space, deflects solar wind like a cosmic umbrella. Without it, the sun's charged particles would strip away the atmosphere in centuries. Mars once had such a field, but it faded. And when it did, the planet's air-thinned oceans vanished and the surface turned to dust. Our planet still holds its pulse, and because of that, we breathe. You exist inside a magnetic heartbeat, a gentle field that hums between sky and soil, unseen but essential. At the planet's edge, near the poles, this magnetic current paints the sky with light. The auroras, ribbons of green and violet fire, are where solar particles collide with oxygen and nitrogen in the upper atmosphere. Each shimmer is an electrical heartbeat traveling through the ionosphere, visible proof that Earth is alive in motion. Auroras aren't just beauty, they're data. They reveal the constant dialogue between Earth and Sun, charged particles spiraling along invisible field lines, energy transformed into color. Every curtain of light you see above the Arctic or Antarctic is a heartbeat written across the sky. Even the oceans beat with time. The Chandler wobble, a small rhythmic tilt in Earth's axis, causes subtle changes in ocean currents and global pressure every 433 days. This, too, is part of the pulse, the shifting of mass and momentum that keeps the planet's balance. It's like the planet rocking itself gently in its sleep. In the Mariana Trench, where the ocean floor drops nearly 11 kilometers, microphones record the faint vibration of tectonic plates moving against each other, the slow breathing of stone. Seismologists call these signals microseisms, and though they are far too soft to feel, they are constant. Even when the Earth seems still, it is whispering beneath you. Volcanoes, too, have their rhythms. Before an eruption, gases shift, magma chambers resonate, the ground trembles at frequencies that can be measured. Infrasound sensors detect these notes long before the surface breaks. Each volcano has a different tone. Mount Etna hums at 0.5 Hertz, while Iceland's Katla murmurs at 0.3. If you could translate those sounds into something audible, it would resemble a planet sighing a deep, resonant breath released after centuries of silence. And when the eruption comes, the Earth exhales heat and minerals back into the atmosphere, renewing the crust, rebalancing its chemistry. Destruction becomes maintenance. Fire becomes restoration. From the crust to the clouds, everything on Earth moves in cycles. The carbon cycle breathes in and out. Plants absorb carbon dioxide, store it in wood and leaf, release it again through decay and fire. The water cycle turns invisibility into life. Vapor condenses, falls. As rain flows to the sea, evaporates again. And through it all, the magnetic pulse of the planet never ceases, guiding migratory birds, whales, even bacteria. There are creatures so small that they navigate by sensing magnetic fields through molecules called cryptochromes in their cells. Each one, from butterfly to dolphin, is tuned to the same silent hum that wraps the world. You are too, even if you've forgotten how to listen. Geophysicists at the European Space Agency have mapped subtle changes in Earth's field using satellites like SWARM. They found that it fluctuates slightly each decade as molten iron currents shift in the outer core. Some regions, like the South Atlantic anomaly, weaken faster than others, allowing cosmic radiation to reach closer to the surface. But the field also renews itself. Every few 100,000 years, it flips north, becomes south, south becomes north. During that time, auroras appear at strange latitudes, compasses lose their bearings, and the planet reconfigures its invisible skin. It's not chaos, it's renewal on a planetary scale. Even magnetic fields need to remember how to rest. NASA scientists once placed ultra-sensitive accelerometers deep in the Pacific seabed. They discovered low-frequency vibrations moving through the entire planet, not from quakes, but from ocean waves colliding across hemispheres. The Earth hums continually even without storms or wind. This hum, a microseismic background, is faint but omnipresent. You might think of it as the sound of Earth dreaming. Every second that sound passes through you, through your bones, your blood, your quiet. You have always been listening. When you walk barefoot, your skin meets that frequency again. Static charge balances, heartbeat meets heartbeat. For a moment, you're no longer separate from the planet, you're synchronized. Your alpha waves merge with Earth's 7.83 Hz, your ions with its field, your stillness with its endless motion. That's not poetry, that's physics made gentle. You are part of Earth's pulse, and Earth is part of yours. The heartbeat of the planet will outlast every empire, every story, every name. It began long before you arrived, and it will continue long after you sleep. But for now, you share the same rhythm, the same quiet, magnetic breath that threads sky to soil, cloud to core, you to everything. You are not walking on Earth, you are walking with it. And tonight, as you drift into rest, that heartbeat continues slow, ancient, alive, carrying you softly in its rhythm, as it has carried all things since the first dawn. You are being held right now. Not by hands, not by walls, but by gravity. It keeps your feet on the floor, your oceans in their basins, your atmosphere wrapped like a soft blanket around the Earth. You cannot see it. You cannot touch it. Yet without it, nothing could stay. Nothing could love. Nothing could remember. Gravity is the invisible architect of everything that exists. Einstein once called it the bending of space-time. He imagined the universe not as emptiness, but as a vast, flexible fabric. When a star, a planet, or even you press against it, the fabric curves and other things follow those curves. That's what we feel as attraction, not a pull, but a path. So, you are not being dragged toward the Earth. You are simply following the shape that space itself makes beneath your feet. You are falling gently into the geometry of being. Every planet, every moon, every star is caught in the same quiet choreography. The Earth orbits the Sun not because it is tied, but because the Sun's mass bends space so elegantly that motion itself becomes a circle, a dance, not a leash. And that dance stretches far beyond your world. It shapes galaxies' enormous spirals of light, billions of stars rotating around invisible centers. At the heart of almost everyone lies a supermassive black hole, millions or even billions of times the mass of the Sun. Yet even these monsters are not destruction. They are design. Their gravity sculpts galaxies into form, gathers chaos into beauty. Without black holes, the Milky Way itself would unravel. When scientists pointed the Event Horizon Telescope at the center of galaxy M87, they captured something that was never meant to be seen, a glowing ring of gas swirling around an absence. That absence, that darkness, is gravity so strong that even light cannot escape. It doesn't shine, it shapes. The black hole at the heart of your own galaxy Sagittarius A rests quietly, 26,000 light-years away. It is not devouring everything. It sleeps. And as it sleeps, it holds your galaxy together, a silent anchor at the center of billions of suns. Gravity is not only cosmic, it lives in your body. The blood flowing to your feet, the rhythm of your heart, adjusting when you lie down, the way your spine curves as you rest, all are small acts of surrender to the same force that binds the stars. NASA's studies aboard the International Space Station show what happens when gravity loosens its grip. Astronauts' bones, thin muscles weaken, fluids rise to the head, faces swell, sleep shifts. The body forgets which way is down. Even the heart beats differently in microgravity, reshaping itself into a more spherical form. Your body, it seems, was designed to trust the pull of home. When meteors fall through the atmosphere, gravity is what pulls them into light. They burn not out of punishment, but out of return, the sky reminding them where they belong. And when comets swing by the sun, their icy tails flare and fade, guided by that same invisible compass. Every orbit, every fall, every return is an act of remembrance. Gravity remembers. There are ripples in this fabric, waves of gravity that move through space itself. In 2015, scientists at LIGO detected them for the first time, confirming Einstein's century-old prediction. Two black holes had collided 1.3 billion years ago, and their merging sent tremors across the universe. By the time those waves reached Earth, they were smaller than a proton, and yet we heard them. The sound was like a sigh, a chirp rising and fading in less than a second. The universe whispering across time, I am still here. Since then, we've recorded dozens more, each one a memory of collision creation and continuity. Gravity doesn't rush. It waits. It shapes everything through patience. Planets form slowly from dust that drifts and clings over millions of years. Stars ignite after centuries of quiet compression. Even galaxies merge in slow motion, taking billions of years to finish their embrace. There is no hurry in the architecture of gravity, only purpose. And perhaps that's the most human lesson it offers, that what lasts is not built through force, but through quiet persistence. Without gravity, the universe would still expand, but it would be shapeless. Stars would scatter, planets would wander, and life would never have found its home. Gravity does not create light. It gives light a place to gather. Every moment you spend grounded, every breath that doesn't drift into the void, every sunrise that returns, they are all small miracles of this unseen architect. You don't need to understand gravity to be held by it. You already are. In the end, gravity is not about mass or distance. It's about connection, the way everything leans gently toward everything else. It's why galaxies cluster, why moons circle planets, why your body finds rest against the earth. It's why you can fall asleep and trust that you will not drift away. Even in silence, you are being held by the same force that carries stars across eternity, the same force that will one day pull them home. And when your body returns to the soil, when atoms scatter and rejoin the dust of other lives, gravity will still be there, folding your remains back into the planet's story, binding you once more into the shape of belonging. You were never separate from the universe. You were its curve, its weight, its quiet surrender. You were never falling. You were always being held. You've wandered far, through stars and storms, through gravity and memory, through light and the long hum of the earth. And now everything is slowing. Your heartbeat begins to match the quiet pulse of the planet. Your breath mirrors the rhythm of clouds moving through the upper sky. Even the neurons in your brain are dimming, not dying, but drifting, synchronizing into waves. You are dissolving into the same stillness that shaped you, and it feels like coming home. Inside your skull, your thalamus, the brain's gentle gatekeeper, is closing its doors one by one. External sound fades. Light once bright turns to an echo. Your prefrontal cortex, the storyteller that always worries, begins to fall silent. It is said enough for today. The pineal gland releases another slow wave of melatonin. Your temperature drops slightly by about 1 degree C, signaling the body that it's safe to rest. Cortisol, the hormone of alertness, retreats. Oxygen slows in the blood. Every system begins to whisper. This is not the absence of life. This is its most peaceful form. If you could watch your own brain right now, you would see something beautiful, millions of neurons pulsing in slow synchrony, a ballet of delta waves rising and falling like tides on an unseen shore. During this phase, known as slow wave sleep, your body begins its quiet restoration. Muscle fibers repair, proteins fold, immune cells patrol, cleaning the corridors of your bloodstream. The glymphatic system in your brain, your inner ocean, flushes out the chemical fragments of thought, making room for tomorrow's light. It's a perfect choreography repeated every night by every creature that dreams. Outside, the stars continue their motion. The Earth has rotated another degree beneath you. Far beyond, 3I Atlas still glides between Mars and the Sun Voyager. One still hums in interstellar darkness, and Sagittarius A still anchors the Milky Way in its patient gravity. None of it stops when you sleep. The universe never sleeps. It only changes form. And in that same way, so do you. Your body begins to enter REM sleep, rapid eye movement, the world of dreams. Your muscles are temporarily paralyzed to protect you from acting out what you see inside your mind. Your eyes flicker behind closed lids, following invisible movements. Heart rate rises slightly. Brain waves resemble waking ones, yet the logic has melted, the edges blurred. Here, your brain replays memories, reorganizes them, and paints them with color. Neuroscientists call this dream synthesis, fragments of experience reassembled into meaning. But science is only part of it. The other part is poetry. Dreams are how the brain remembers emotion when language is asleep. In your dreams, the rules of physics soften. Gravity bends into imagination. Time folds. People you have lost return, but not to stay, only to remind you that memory has no walls. Your subconscious wanders through constellations of thought, fear, joy, love, fragments of light and place. It builds cities from feelings, oceans from whispers, and you somewhere in the center float without direction, carried by the current of your own mind. This is the brain at its most creative, its most forgiving. It edits without pain, rewrites without guilt. Dreaming is how you heal the invisible. Outside dawn is beginning its slow rehearsal. The ionosphere brightens. Birds will soon begin their faint magnetic migration toward the rising light. Every particle of air is preparing for day. But inside, you are not ready to wake. You are drifting deeper into that fragile place between consciousness and calm, where thought stops forming words, where time no longer keeps count. The reticular formation in your brainstem maintains your slow breathing. Your parasympathetic nervous system keeps your heart steady, ensuring that even in surrender, you remain alive and whole. You have become a system of trust. Everything you've learned from the stars, from the body, from the ancient hum beneath your feet, now lives quietly inside you. The atoms in your cells were forged in stellar cores. The iron in your blood was once the dust of a dying sun. The rhythm in your chest is the echo of planetary motion. Even your dreams are made of recycled light. You are not a visitor here. You are the continuation of everything that ever was. In one of NASA's deepest images, there's a faint galaxy, just a smear of light, 12 billion years old. Its photons have traveled across space and time just to meet your eyes. When you looked at that image once, perhaps you didn't realize you were the final surface that light would ever touch. It began before your planet existed, and yet it ended in you. That's the secret of everything you've heard tonight. The universe doesn't exist out there. It exists through you. Every discovery, every pulse, every breath, they only become real when you let them pass through your quiet awareness. The cosmos observes itself through your rest. You are at last at the end of the story, but not an ending, a pause, a breath. Light becomes rhythm. Rhythm becomes stillness. Stillness becomes sleep. And somewhere beneath all of it, the earth keeps humming. The sun keeps burning. The universe keeps remembering. And you small and infinite, you fall gently into that memory, becoming part of the silence that shaped you. Sleep well, dream gently. Good night.